I think today's question is quite pretty. We are given a diagram with concentric semicircles and a few squares side by side. With the choice of color palette for the semicircles, it seems as if sunset is descending over blocks of squares of cities. We are told that the area of the leftmost square is 4 and are required to figure out the area of the rightmost square. So let's take a look at the diagram. We have 3 semicircles, all with the same center, which is the red dot. The radii of the first semicircle, as you can see, is denoted in blue. The radii of the second largest semicircle is in green, while the radii of the final biggest semicircle is in purple. With this said, we can label the side length of the square next to the one with area 4 as x. The radius in green of the second semicircle must then be x plus 2, as labelled in the diagram. Now comes the interesting part. If we draw in the diagonal of the square, you will see that it is precisely the radius of the second semicircle. The diagonal of a square is a hypotenuse of the right angle triangle with side length x, so we can conclude that x squared plus x squared equals the diagonal square, which happens to equal the radius square, in our case, x plus 2 square, through usage of the Pythagoras theorem. We can then solve for x to get x equals 2 plus 2 square root 2. We can continue labeling the side lengths of the third square, which happens to just be x plus 2, from the work we have done previously. Since we are seeking the area of the final square, it also makes sense to label it as an unknown. We will let it be y in this case, for the side length of a final square. Can you foresee how could we proceed next? If I draw in this purple dotted line, do you get a sense of deja vu? That's right, we will just evaluate the same purple radius in 2 ways, as we have done before, making good use of the Pythagoras theorem again. The Pythagoras theorem gives the diagonal square, which is also the radius square in our case, as x plus 2 square plus x plus 2 square. At the same time, the radius also equals x plus 2 plus y, as labelled in purple in our diagram. So the radius square equals x plus 2 plus y square. We could then equate the two expressions and take square root to get square root 2 times x plus 2 equals x plus 2 plus y. Remember that we have gotten the value of x from earlier? Well, substituting the value of x as 2 plus 2 square root 2 allows us to get the following expression, of which we could expand the bracket and subsequently solve for the value of y, which is 2 times square root 2. Finally, to obtain the area of the square, we just square 2 times square root 2 to get 8, which is the answer we seek. Please leave a thumbs up and subscribe if you have enjoyed today's question, as this really motivates me to keep producing more quality content. I will see you in the next video, and until then, bye.